Hey guys, welcome back to my YouTube channel, and the topic for today is metallic bonds. Now as you can see, this is the basic structure of a metallic bond, and here's the basic definition. In metals, the atoms are tightly packed together in a regular lattice. The tightly packing allows outer electrons to separate from their atoms. The result is a lattice of ions in a sea of electrons. This is very important, a sea of electrons that are free to move. The metallic bond is attraction between metal ions and free electrons. Now these small things are called the sea of electrons. When you draw an atom, you always have to draw these tiny things with a minus sign, and these larger ones always have to have a plus sign, right? Now I know it's written that they're tightly packed together, but this diagram is enlarged in order to make things clearer. However, when you have to draw it, you have to draw the atoms much closer together. Now I'm going to discuss a few characteristics of the metals in relation to this diagram in order to make things much clearer. Okay, so the first point is metals usually have high melting points. Now this is because it takes a lot of heat energy to break up the lattice with its strong metallic bonds. Now an example can be copper. Copper melts at 183 degrees Celsius and nickel at 145. This is because their atoms are very close together and they have a very high boiling or melting point, right? Now, however, there are some exceptions. For example, sodium, which melts at 98 degrees Celsius, but mostly metals have very high melting points. Now I'm giving you 5 seconds. If you haven't subscribed yet, please do so. I'm counting to 5 and I want you to do it now. Thank you. 1, 2, 3, 4, 5. Back to the topic. So we've done this. Now metals are malleable and ductile. Now the term malleable means they can be bent and pressed into shape. This is useful for making, for example, car bodies, because when you have to shape a car, you have to bend the basic structure in order to make a good design, right? So malleable means they can be bent and pressed into shape. Ductile means they can be drawn out into wire. This is usually used in the case of copper, where electric wires are made. So the reason because both of these things can be done is because the layers can slide over each other. Now I've got a diagram over here which shows it more clearly why metals are malleable and ductile. So for example, if force is applied over here, okay, a lot of force, right? Now these atoms, they're tightly packed together. There's hardly any space, okay? So when force is applied, the metals are pushed forward. For example, this is pushed forward in that direction, and therefore the metals are slide over each other. So this is the second diagram. Can you see the metals are sliding away in this direction? This explains why the metals can be called malleable and ductile. The third characteristic of a metal is they are very good conductors of heat. Now why is this? This is because the free electrons take in heat energy, which make them move faster. They quickly transfer the heat throughout the metal structure. So as I've shown over here, these are the free electrons and they're free to move. They can go anywhere they want, right? So here we are. Free electrons take in heat energy, which make them move much faster, okay? These are the electrons. They can move here and there very fast, and they quickly transfer the heat throughout the metal structure. For example, I've applied heating. I put this on fire over here, this one, okay? So now this one has been heated. It will move and heat this one, and so it will heat this one, and so on, and therefore within a short time the entire metal structure will be heated. And now for the final aspect, which is metals are good conductors of electricity. Now this is also a very important part, because almost all metals are good conductors of electricity. That is because the free electrons can move throughout the lattice carrying a charge, right, when a voltage is applied across the metal. So if I've connected two wires over here, and this one I've charged this particle, obviously it will start moving here and there, and therefore charge other particles, and therefore the electricity will be transferred from here to the end of the metal, and therefore you can call it that they are good conductors of electricity, right? Now, if a question comes that why are metals a good conductor of electricity, you simply have to mention this point, that they have a sea of electrons. Your answer will most probably not be accepted if you do not mention this, okay? They have a sea of electrons, which is why they can easily transfer or carry electrical charges, okay? Now in this video, I'm giving a special, let's say an incentive, that whoever subscribes to my channel from 5 different devices and sends me the picture on my email account, I will give them a free copy of the questions from 2006 to 2009, all of the CAIE past paper questions regarding this topic. And furthermore, that person who does subscribe from 5 different devices, he will be given one free Zoom class of 20 minutes in order to discuss any problems you face, okay? Now this offer will only and only last till 6:30 today, so please send me the email by at least 5:40 in order to gain your reward. Thank you. And if you haven't, now I'm working really hard in order to help you guys out, so the least you can do is at least subscribe and share my channel so that I can grow and help others as well. Thank you and goodbye.